Today I'm going to look at 3 new motors for 2019. They're brushless motors primarily used in touring car, competition racing and blinky racing in particular, where you're not allowed boosted RPM from the speed control. And I've looked at many motors up to now, so we'll see if they're any better. They're still making advances on these motors, making them a bit better. They're called spec motors and they're supposed to be built to specification and all should come out about the same, but we have found that the variation is huge and some are a lot better than others. Often due to cost cutting they underperform. Anyway, these are the top motors you can buy. Up to now, the ones that have been winning races are ones like the Surpass came in and been doing very well, good motor. The SMC, a particularly good competitive motor, unusual design, lightweight. And a favourite of mine, though not very well known or used, the Phantom Icon. And other motors like the R1 Zombie. I don't have any to show you here, but they've been around for some time and are race winning. But what about the new ones? Well, we've got these Revtech XFactor motors. They're available in for spec racing. They've got a 10.5, 13.5, 75, 21.5 and 25.5 versions. And I've got 3 here, the 17.5, 13.5 and 10.5. I'm only going to really check out the 17.5 and 13.5. We'll look at them in detail. They're a nice unusual design. Another motor is a new one, is the Orca. Now it's called the Blitreme2, and the Blitreme1 was quite a good motor in my testing. Wasn't well received or used, but it was still a good motor. And this is a version 2, Blitreme 2, which is an improved version of that one. So we'll look at that. And then you come to the Hobbywing. Now the Hobbywing is now the new G3R version of the G3. It looks exactly the same as the G3, but we'll look at what they say about it and how it's been improved, because when I tested the G3 I found that for spec racing, we're talking about like 13.5, 17.5, the rotor strength was much too weak. Gave very good KV, but if you can maintain a high speed, but it had poor torque, especially out of the corners, and so couldn't really deliver the results. So I'm going to take them apart and show you what's inside. I'll do all the measurements as usual, using testing rotor strength, resistance of the stator windings, set it up and compare KVs for a certain amp draw. I can measure all the sizes of things and the weight. And I've also got charts of all the previous motors that I've tested and their results, and we can compare, especially when we're looking at the say the Blitreme and the G3, which I've got results on. Of course, the Revtech's a brand new design, so I won't really be comparing that to anything else, but be comparing it to the ones that are winning races. Where to start? Well, the Revtech, I've got one open here. It's the open construction and no screws all the way through. They've gone to a number of the recent motors coming out now. They're just fixed at the end, done away with the screw that goes through front to back, which can actually reduce the performance of the motor unless it's made out of titanium or aluminium, or as in the SMC, positioned in such a way to reduce the effect. And you can look at the construction inside and out, so I'll look at that a bit later in detail. It's a nice looking motor. It looks a bit weak at these sort of arms that stick out and hold the front in a very heavy impact. Let's hope they don't bend in any way. And as I said, I'll weigh all these. Weight is becoming important. They're trying to get lighter and lighter, And in fact the G3 I think was one of the lightest along with the SMC. And then we'll look at the G3 in detail. Here's one here. It's got this open can design. I should have mentioned that when I spoke about the SMC. It's two ends clamped together and you've got the stator laminations exposed in the middle. Now that is basically what SMC also did with their design. As you can see, they've clamped the ends onto the stator. Flush, these are slightly raised up, not much in it, but it's the same idea, which means they come out very lightweight. And SMC took it a bit further with having offset holes, so you can raise and lower the motor slightly depending on which holes you mount it in. The SMC is one of the smallest and lightest I've tested. It's an unusual motor in performance wise, it's very high revving. Now the Orca, it's one of the motors that exposes the stator, but not so much the coils. It has got holes at the front, the back's hole here and here. It's slightly restricted in airflow. Again, black is the colour most people want. It's fractionally longer, and you can see it also has a very long shaft compared to the Hobbywing. Hobbywing's tried to save weight in every way, even shortness of shaft. The SMC, also a very short motor, very short, really shows up there how short it is. And it's quite a long shaft length on the SMC compared to the Hobbywing. Just looking at the Orca, it's got 3 screws in the back, single port. Nice legend here, which is, and a little pointer, which is fairly clear to see. A lot of them you can't even read that after a while, especially if it gets dirty. Blitreme2, it says. Screws go all the way through, so it's a pretty conventional design there. It's screwed from the front all the way to the back. Some of them are screwed from the back to the front, so as you can see on the Hobbywing, it still uses a screw from the back, screwed all the way to the front, holding it together. Unusual with the Hobbywing, it's a single screw in the middle for adjusting the timing. Just back that off 2mm. It's got a scale here, but the pointer is not coloured. It's a raised bit of plastic. It's not the easiest thing to see, but it's there, shimmed okay. And it's open front and back for the airflow, including the front where the collector is just a ring on the outside, which is not the best we found for performance. On the SMC they use a standard collector, which is a fairly thin plate. On the Blitreme, you can't see it, but it's got a larger silver plated collector, which on my test has shown up to be the best way to go. So it just shows the number of variations on design that you can get with these motors. It's just amazing how many ideas the engineers can think up to keep within the rules. Solid tags, very thick on that one, pretty thick on that one, and this is slightly different material on here. Could be it's plated. I wouldn't say it was silver though. And the Surpass, I've got one here just in comparison. It's the red one, pretty typical, short shaft, very short, and they were the first ones I think to cut the flat all the way down, so you don't have any problem getting your pinion to go on the flat. 3 screws on the back of that one. 2 ports, top and, which makes it useful for putting in all sorts of cars from LMP, buggers and that, where you can't get access to that sensor port. All these other ones have 1 port on the back there. This one's got a port on the top, and this one has a single port on the back as well. So many variations are thought up. 3 screws hold that one, 2 screws hold that one, 1 screw on that one, 3 on that one. so many different ways of doing it. And of course I haven't even completed this one because it's the XFactor is totally different again. It's got exposed bearing. You'll notice that most of these, the rear bearing is enclosed. That one you can see it. This one you can see it. Bit unusual to do the timing on this one. There appears to be no screws holding it together except 3 there, which you would think were holding the whole motor together. In fact, you loosen those 3 screws off, and which actually the timing screws, you can turn this blue part as well. It holds it together, the whole motor together, as well as doing the timing, so that was quite clever. It's quite difficult to turn. I found some of them, because it's held with the internal ring, they're very stiff to turn. Nice big scale, easy to see. A little white pointer, not quite so easy to see, but better than some. Again, a different sort of tag. This is vertical ones with cutouts that you lay the wire in. I'm not sure which one is best for people to solder. I normally find that these ones we solder on top are good. These are quite rock solid. Some of them flop around. I think the R1 was particularly bad, and you could actually short these out in the end if you're not careful. Long shaft, quite a problem, these long shafts. They will hit the side of some batteries on some touring cars. And also, very bad, the flat ends so far from the face, miles from the face. You've got to put your pinion on right up to the front. The grub screw is going to have no flat to go on. Just look at some of the claims that they've made before I show you the results I found. The XFactor made some good claims. I think I spoke about this in an earlier video. They've saved weight. They talk about a better sensor board. All these motors suffer from sensor board variations. You can get a good one, you can get a bad one. No one seems to have got it 100% for every motor. They keep trying. Big adjustment, 0 to 60. Some of them don't go that far, most do. 6 short screws, well actually 3 are inside. That's actually holding the sensor board to the back plate, so there's only 3 really. X-flowing, I don't know, X-flow cooling, not sure what they mean by that. Unflow resistance. No fade stator design. Well, I don't know if there is such a thing as a new stator design with no fade. They're all trying to get that. High torque, rotor copper, etc, etc. Funny enough, I could not find any interesting data about the Blitreme2. I don't know if they put any up yet, but the Orca Blitreme2 didn't find anything specific. But there are some very specific claims made about the new G3R motor. And it's quite interesting because when I tested it originally, I said the motor magnetic strength was much too weak. So now they say the torque of the G3R is improved by 13.3%, which is what we want. kV and max output power are improved by 6.5 and 8.6%. They're very specific about the percentage. I mean, 8.6, you think it's going to be some variation. They should have really rounded this out to 9 and 13. I mean, no motor comes out the same, so they're never all going to be 8.6% better. But we've got to calculate, we'll see after I check it whether these figures are true. Low resistance, high efficiency. Resistance of the G3R was reduced by 11%. Well, I can easily check that because I've got a meter that measures very accurately. The resistance, efficiency is improved. Difficult to measure. I've got a dyno. I'm not mad on the dyno at the moment. The software isn't perfect and it's very time consuming to try and measure the efficiency curves. Lightweight, 139 grams, 8.6 lighter than some popular stock motors. Well, I'll show you the weights later. It is lightweight. High precision Hall sensor, well, they all try that. High precision balance rotor, they all should have that. Motor cage designed for easy to dismantle, that's quite good because some of them are really difficult to get apart and back together again. Placement of common wearing parts, what do I mean by that? Bearing, common wearing part, the only thing that wears is the bearing eventually, if you get it wet especially. Otherwise the rotor shouldn't lose its magnetism unless it's not very well made, and the stator windings won't wear out unless you burn them out. Maybe that's what they mean. Special shell design, stator core exposed to the air, maximize cooling, big holes, yeah, all good. High performance stator core. Stator core heat 200 degrees C resistant wire. Yeah, that's brilliant if it is. I mean, the wire's a problem in the olden days. Used to easily boil off the enamel and short out. So that's, if it is that resistant, it's not going to short and burn out. 180 degrees resistant rotor. The rotor does get very strong, very hot, and it can lose magnetism, but it should come back again if they've used proper magnetic materials. So rarely are rotors made cheap enough to lose their magnetism, and I've seen some, not so many these days. High precision, high strength bearings. Interesting with the G3R and the G3 that the rear bearing in the bell end, in the timing end, is smaller than any other motor. It's a metric. They've turned down the end of the shaft to 3mm. It's a smaller bearing which saves some weight. A bit difficult if you decide to change it, make sure you get the right one. Copper solder tabs with super current endurance, guarantees outstanding performance and super durability. Well, okay, complies with all these people. So there's quite a lot of claims by the Hobbywing, more than anyone else, very specific about the percentages. So I've got, for instance, last time I measured the Hobbywing, I've got some results here. I measured the G3, 13.5, and I got a kV reading, I got a wire resistance reading, I got the magnetic strength reading, I got the weight. So it'd be very easy now to compare the 13.5 G3R and test this one, see what percentage variations we get. And I've got the results from, for instance, the Surpass. I've got the SMC, other high torque motive, for instance, and the R1V21, which I believe you can't use in competition anymore. And I've got others, 13.5s, 17.5s, and 13.5s, Phantom, Icon, McLaren, SMP, etc., etc. So I'll edit all this together for you and then go over the conclusions. A quick look at the conclusions, and I'm going to look at specifically the Hobbywing G3R 13.5. So I've measured the results, and I've got the results from the previous G3 version. And just look at a couple of things that I've found. So looking at this sheet that they put out, they said that the kV has been improved by 6.5%. So let's have a look. Now it's very difficult to measure the kV because you have to specify what timing you're measuring it at, and the kV is offload obviously. So we've got a calculator here. Now the Hobbywing G3 13.5 set up at 6 amps, and I measured the kV at 3878. So let's put in 3878. Now they say it should have improved by 6.5%. They don't say at what timing, so we'll do it. So according to that, the kV should have gone up to 4,130. And what did we get? Hobbywing G3R kV 3940. So it's gone from 3878 to 3940, which is hardly an improvement at all. It's certainly not 6.5% on this sample. Let's look at some other claims they've made. They made one about the resistance. Low resistance. The resistance is reduced by 11%. So let's have a look. Well, I measured the resistance at 0.026. 0.026 times 11% minus should be now 0.023, and what did I get? 0.023. So that claim is spot on. Anything else we can compare? Well, I mentioned the weight. Lightweight is 8.6 lighter than some popular stock. Well, they don't say which ones. What weight did I get? Well, look at the original G3 weighed 132.4 grams. The new G3R 138.1 grams. It's actually gone up in weight, which is unusual, but it is still very lightweight. Let's have a look at some of the other weights here. Let's just back it up a bit for you. The Blitreme2 is pretty heavy, 155.8. The Trinity XFactor 145.2. The Phantom Icon with pins, there's hardly any weight difference with or without pins, 147. McLaren 151. SMC 136.1. So the SMC is now lighter than the Hobbywing. It wasn't originally. Originally it was 132.4. So, and now the SMC has taken the crown in the 13.5. What about 17.5? Well, I've got the results here. G3R 136.8, SMC 136.8 grams for the 17.5. Hobbywing 136.8. So they are now equal lowest weight. Trinity XFactor 145.2 is not far behind, it's very light, and the Phantom Icon without pins 141. So a lot of these motors are pretty lightweight. 149, and the Surpass was 151.7, but the Hobbywing is definitely the lightest motor with the SMC. Any other claims we can have a look at that they make that I can actually measure? I'm not going to put it on the dyno to do the output power, torque or efficiency. Okay, that's probably the only ones I can compare. So let's go over some of the actual results now. Let's look at the results of these three motors, the G3R, the Blitreme2 and the XFactor. I'm going to look at the 17.5 turn results, just compare them, these three, to each other. They're most recent motors really that have come out. Weight, we've already shown that the Hobbywing is the lightest by quite a lot. Some people may not want a very light motor, but they're getting lighter all the time than what they used to be. Shaft protrusion, the Hobbywing is very short, which most people will like in the touring car. The Blitreme2 is long, as is the Trinity, and the flat on the Trinity is not good. It's only halfway down the shaft. Let's look at the kV. This is a thing that tells you how good the motor's going to be in conjunction with the torque with the Gauss of the rotor. 3338 for the Trinity, 3230 for the Orca, 3241 for the Hobbywing. So the Trinity is a little bit revier, and in fact I tested two Trinities and I had the second one was 3449, so a useful jump over these two. Trinity. Stator resistance, now this will give you an indication if the motor is going to get hot, wasted energy heating up the wires. The lowest windings I think I've had was 17.5. Let's have a quick look at this. Was the R1 at 0.035 we've had. Of course the R1 is not allowed at the moment, and the SMC very low, 0.035. I think I even close to 0.034. Most are 0.037. It's very typical. What did we get here? 0.037 with the Hobbywing, 0.037 with the Trinity, and the Blitreme I had quite a variation on the windings, 0.038, 0.039, 0.040, which is, looking at them, you would think they'd be fine. I don't know why the resistance varied so much on that one. Another thing you must check, and some motors have been falling foul of this now, is the actual stator length, 19.30 millimeters minimum, and that is the length of the laminations from front to back, not including any epoxy that's on the end. So you've got to measure the actual lamination length, and they will vary. These are manufactured by squeezing a lot of little plates together, and they are stuck with some special glue squeezed up. When they release them, they can open up slightly, and some bits can be a little bit wider, but it's the narrow part we're looking for. I did check them over. If they left the lamination off, it would go under. I think some motors have suffered from this when they've been checked. Hobbywing closest 1938. I measured. Orca playing it safe, they probably got one extra lamb on, 1975. XFactor, again, they didn't want to push the envelope, 1942. It's a slight variation in when they're manufactured, so if they took a lamb out, they'd go under. So they're aiming as small as possible. The Orca, I think, it plays a little bit safe. Now, you can't just go by the KV, you've got to look at the torque, rotor Gauss. And one thing with the Hobbywing, let me show you the original Hobbywing. That's another thing we can look at that I didn't mention. The Hobbywing 13.5. One reason why it was not a successful motor is they still had a weak Gauss in the rotor. The one I measured here, 13, average about 1320. It's not good enough now for touring cars. We're looking for at least 1500, 1550, 1600. 1500 is where we're aiming for. These motors, race winning motors, are 1500, 1540, surpass 1500. So the Hobbywing missed out by miles. It's right down in the 1300, so that's why it didn't work out. And let's have a look at that was 13.5. Let's see what we got when I tested it now. Well, this one, the 13.5 G3R, got 1461 and minus 1476, say about 1470. So a massive jump in the right direction. I think they should have taken a bit more and got it over 1500. If they'd got it up to 1550, I think they would have, or 1530, a bit more. They're still playing conservative. I don't know why. Go back to the 17.5s. 1436 to 1457, about 1450, as opposed to about 1470 on that one. I took them both out. So there's still variations on the rotors. You would think they could get them a bit tighter tolerance. So this one's a bit weak. I would say they really need to take it higher. Well, a big problem here, Orca Blitreme 1351. Why have they put such a weak rotor in? It doesn't make sense in this day and age. They must test motors, they must run them in cars, they must look at other people's. I don't know why they've done that. And normally a weak rotor will give you a massive high kV, which it hasn't. Disappointing there. But let's look at the XFactor. Look at this, 1599 minus 1614, 1600. Well, in the past, if you put that in a motor from 2 or 3 years ago, it would just not perform high speed. But they've sussed it all out, and not only got a high torque rotor, you've got excellent kV. This motor is really something special. I would say it's possibly the new class leader of all motors. To get a torque like that rotor and get a kV, it's going to be really powerful out the corners and get a top speed. Weight's good too. What can I say? That is exceptional. How does it compare to something that went before? Let's have a look. 17.5s surpass 1500, over 1500, Motive 1500, Phantom over 1500. So that is gone exactly the right way. The results for the 13.5 turn motors, I've got them here. The XFactor, the Blitreme2, the G3R, and above you can see some of the other motors that are very good. Let's have a look bit by bit. I've already mentioned the weight, so let's look at the kVs, the all important kV. A lot of people look at this. I set it up for 6 amps. So similar, 3969, 3945, 3940. So how would you decide that if you went on kV alone, you think these are all going to be the same? But you can't. You've got to look at the rotor strength as well. And just before we do that, we look at some of the rotors that went before. SMC, very high rev, and we know that, and you have to gear it differently. McLaren, rev well. Phantom, rev well. Surpass, lower, but that's quite a torquey motor, and we know it pulls and does very well as well. Before we look at the rotor strength, let's just look at the resistances. 2.1 is about as low as you can go. SMC achieved that. 2.2 is normal. 2.2, 2.223, 2.3, and the new ones, Trinity 2.2, Orca 2.2, 3 and 4. Again, a variation I've found the same as on the 17.5, but this one's in the ballpark. The 17.5 was a bit high on the resistance, and the Hobbywing 2.3. The Trinity is edging it there. And then finally, let's look at the torque strength. Just like in the 75, 1600 Gauss rotor, plenty of torque and revs good as well. That is a class leading performance. Unusually, the Orca has got a 1500 rotor in the 13.5. In the so I don't know what's going on. In the 17.5 it was only 1350. I don't know if they've got some sort of production problem. It's exactly the same massive long code on both. It's not like it's a different rotor. I measured it and everything. The size, it's the same, but the way out on that 17.5. This one hits the spot, 1500. What about the Hobbywing? They said they have improved the torque, etc, etc. I mentioned earlier. In my opinion, okay, it's the right area. Maybe they copied something that was existing like the R1, but I think they should have pushed it a bit more into the 1500s. They know more about motors than I do. All I do is observe and results. Maybe the combination will work. It is the lightest motor with the SMC, so that's good. So if you ever swap your motors from, if you had two, Hobbywing and an Orca or some other, and you took it out and soldered the other one in and go and race and find it or if you put the Hobbywing, you find the car be underweight and you get disqualified, so you're going to have to watch that. Shaft length, I spoke about that. The Orca's very long, 15.5, the Trinity's long, Hobbywing nice and short. Nice and short, very short, shortest by miles. Even the Surpass at 14mm is still a millimetre longer than that. And the conclusions, I think the Trinity XFactor is the best. If I had to buy a motor now, I'd buy that without any problems at all. Hobbywing, I'd like to see how it goes. The Orca, if you've got the strong rotor, I think you'll be alright. This 13.5 one, I think will be fine. The 17.5 one, the test, maybe I had a bad one or something. I didn't like it at all. And the winding resistance was high as well, which maybe it'd be alright on the track. There they are, the three latest, I would say, XFactor all the way. Hobbywing, hopefully it's going to be better than the previous one. They have improved it. They have improved it. And if you get a good Orca, I think you'll be fine. I hope they don't vary very much when you buy them. 2019, other motors, as I've already mentioned, I like the Phantom. SMC is a good motor. If you can gear it, a lot of people have trouble gearing it. The Surpass, we know, it's very easy to use. People don't have any trouble gearing, they get it to work fine. It's a good all-round motor that will give you top-end race-winning performance. Hopefully that wasn't too long for you, but it does show how the engineers, manufacturers keep trying to push the envelope, trying to get a race-winning motor. And there's still a couple of faults on even the best motor. That shaft is way wrong. And I think there's still room for improvements on some of these motors as well. Not only in the cooling, but the rotor strength, maybe the windings. There's just room still. Someone's going to eventually improve these even more.